Okay, so hello everyone. Here we are for the last talk of today. And I'm Mattia MANZATI, and today we'll speak about Mutable or Immutable, and why not do both? So first of all, thanks to our sponsor, to the conference, thanks to the organizers, thanks to the audience, to the location, thanks to everyone. Someone of you may already have read some of my articles about Redux, for example, about how to manage state with Redux for authentication. And hope you had a nice coffee break. As you may already have noticed, I'm Italian. So let's start by speaking about state management. Is state management easy? Well, not in Italy. Yeah, I think exactly, not in Italy and not even in the rest of the world. State management is one of the hardest topics in the React community. And the slide's stuck. Yeah. Okay. So just give me a moment because it got stuck. As always, live break everything. Okay. Okay. Are you back up and running? Okay. So if you start Googling state management in React, you'll probably end up finding two solutions. And those solutions are Redux, and the other solution, I think, is MobX. But if you are new to the React community, you haven't touched React yet, your first question will be for sure, which one should I pick between them? And between Redux or MobX, as a developer, we always answer, it depends. And slides keep not updating. Okay. So I'll do that. Okay, live only slide. We'd say it depends. Because they are actually opposite patterns. When we speak about Redux, we speak about immutable state management. And immutable state management have its pros. But as we said before, with Eric talk about Redux forms, it also have downsides, because whenever you change something, you have actions that continuously change your state, you're stressing your application. While using Mutable management solution give better performance in those edge cases. Let's start giving a look at both solutions by seeing how they handle the data shape. With the Redux, we are dealing with immutable objects. So with immutable objects, we write code that's mostly focused on data changing. So we are producing new objects. So in our code, we will always produce new objects, so our code will be around data transformation. And our data shape will be kind of lost in all that code. Also, one of the problem of Redux is that actions aren't collocated with reducers. So always happens that you have a reducer with a lot of line of codes that have a lot of actions, but you don't actually know those actions, which parameters take, how they should be called, because sometimes they are located on another file. On the other side, the MobX community use the EX6 classes. And that's nice, because with a clean code, we can see immediately which are the properties of our object and which are the actions of the object. So we can see immediately which is the shape of our state. So as we said, with MobX, shape is clear, and with Redux, we get kind of lost. Let's speak just a second about data rehydration. Imagine that we have those kind of data incoming from the server. when you are dealing with immutable structures, it's really easy to rehydrate those data into our store. And that's predictable because our data doesn't contain any business logic at all. Our store is just values. It doesn't contain actions. It doesn't contain any derived data. So we can just pick up the value from the server and inject into the reducer to update the existing value of the store. On the other hand, in the MobX community, this is a real problem because for each store, we need to define a function and a getter to either serialize and deserialize our data shape. And that's because classes have an internal state. Mutable objects have an internal state. They doesn't externalize your state. So as we said, with MobX, we have the problem of internal state, but with Redux instead, we can just pick up the object from a server and use it immediately in our store. But we know Redux has changed how we think React development and how we use it. Because thanks to the snapshot that are immutable, we can provide a lot of nice features like time traveling. We can make testing easier. We can use snapshot testing, for example. And we also have better dev tools because the dev tools can keep track through the life of the object, how they look like at that moment, and how they changed. So those benefits are awesome. But if we want to have them in MobX, we have to write a lot of line of code. As we said before, we need to manually write serialization, deserialization functions. Wouldn't it be nice to get them for free from a MobX observable? Well, if you think about it, to get them for free, you actually need two things. You need to know, one, how our data is shaped. So you need to know exactly which properties are expected in our data. And you need to know how to serialize back and forward your data. So wouldn't it be awesome to get the best of both worlds? Well, today we'll discover MobX-State-Tree. That's a project, an opinionated state management solution that use the best of both worlds and try to merge them together. Let's start by giving a look at how we define our data shape. In the core of MobX-State-Tree, there's the concept of a model. We can think as model as our React components, but for data. Inside our models, we define the properties of each model, and we can provide a default value that will be used in our model. Then we can optionally enrich our model with actions. For example, here, I enriched my to-do type model with a toggle action that simply toggles the state of our to-do. So with MobX-State-Tree, we get a data shape that is clear. With watching our code, we can see immediately how it's shaped. And we also have collocated action because they are next to our state shape. But now that we have defined our model type, we need to create an instance of it because the model definition is just a shape definition. We need to get a concrete type that we use inside our views and our application. To do that, we simply type .create followed by the model name, and we will get a fresh new instance of our object that will have our actions that we defined before and our properties that we defined before with the provided defaults. And getting an instance snapshot come for free. You can get an immutable representation of the state of your mutable object for free. You just import the getSnapshot function from MobX-State-Tree package, and you provide the getSnapshot function a MobX-State-Tree instance, and it will give back an immutable representation of that object. For example, here we have back our name and our done. As you can see, the toggle function is omitted because it could not be represented as immutable data. And interestingly, we can do the same thing even to create a new instance. So for example, we just pass in the server data to our todo.create function, or apply back to an existing instance, an existing immutable snapshot, so the data from our server. And what the MobX-State-Tree will do is update our mutable object to make the snapshot of that object match the provided one. The awesome feature is that thanks to MobX reactive data structures, we could also listen for snapshot changes. So whenever something changes in our store, we can get a new snapshot for free, and we can do whatever we want with that. For example, we can store that snapshot on the local storage, and on the next boot of our application, we can just get the snapshot from the local storage, pass it to do the store.create function, and rehydrate the store as it was before. So we have autosave functionality for free, like you would do with Redux applications. Let's have a simple example. Here I have a small to-do task application. I can change a to-do. I can add a new one. For example, I can add attend React Alicante. Okay. And we can see, hope the code is big enough. Can you see it well? Okay. You see that we have an immutable representation of our store, and we can travel back in time into our immutable representation and see what's changed during our application execution, like you would do with Redux applications. But as we see, we are dealing with mutable data structures. Back to the presentation. So having immutable data representation actually means that we could implement those fancy time traveling that Redux provides. And if you think about it, given those three functions we've just seen, it became really straightforward. You just need a list that will store your application state during its execution. Every time a new application state is emitted, you subscribe to it and you push into your application state list. And if you want to go back in time, you just apply back that snapshot onto your store by providing the application state snapshot we used or we want. So with MobX-State-Tree, we get MobX observable object that produces automatically immutable snapshots that can be used to create new observable objects or to update existing ones. And we can get also time traveling for free. But as we think about it, models aren't just the only thing you encounter in your application, because our application isn't just about models, but rather about a tree of models. So we need to compose our models, just like we do with React components. We have a component to create an application. We compose a set of components. With MobX-State-Tree, there is a types namespace where you have some types that you can use to enhance existing ones. For example, here I'm creating a new model that uses types.array, so we'll use an array of given to-do we defined before. So with this example, we'll create a to-do store application that will have a to-dos array. And features we've seen before will continue to work as expected. For example, we can create a new to-do store back from a snapshot that is a list of our to-dos. So even if composed, they will continue to work as expected. And same goes for actions. Even if we provide our application snapshot to a composite type, we will get back for free our application MobX instance with our actions. And there's more. Because MobX-State-Tree knows that to-dos is an array of to-do objects, you can even push snapshot not only at the root of your application store, but even at the leaf. For example, here I'm pushing a new to-do on the list, and we can see that we can have the action that we defined on the to-do model right before we push it onto the list. So every time we push a snapshot into a property of our models, they will be automatically converted to a MobX-State-Tree instance. As we've just seen, types are a strong part of the MobX-State-Tree package. When I showed you this syntax, I kind of lied, because this isn't the right syntax. This syntax is just an alias. You can use it, but it's just an alias of a longer syntax that provides exactly the type you're providing for each property. For example, here I said before, okay, name by default is an empty string, and done is false. What MobX-State-Tree is doing behind the scene is inferring the type from the primitive. So it's saying, okay, you said empty string, so you meant, okay, that property is optional in your snapshot. If not given in your snapshot, this property will be a string with the default value of blank. Same goes for the done property. And one of the benefits of having a runtime type checker is for sure type checking. So in MobX-State-Tree, whenever you try to create a new object from a snapshot that doesn't actually match the model definition, you end up having an error. And he will say exactly at which path that property is invalid and what he expected. For example, he say that at the name value is value false is not assignable because he expected a string, but he received a Boolean. And the other fun thing is that with that syntax, we get for free TypeScript and support and auto-completion. That's because TypeScript is smart enough to infer the types of each property we've defined before by just looking at its value. Behind the scene, we have typings that do that. They say that types.string means string for TypeScript. So we provide, by default, only TypeScript support, just because we are much into TypeScript and less into Flow. So if someone wants to push a PR about Flow support, it's really welcome. So with MobX-State-Tree, we get runtime and build time type checking. And this makes developer very happy. It makes developer very happy because our state will be always consistent with our definition. We won't have an illegal state in our application store. If our application store has an illegal state, our application will throw immediately. And the types namespace actually provides a lot of types. They are inspired by the work of Giulio Canti over the TCOM library that provides type combinators for JavaScript. And it's the type system behind the MobX-State-Tree has been heavily inspired by his work. So you have not just JavaScript types, but you even have types that are usually of other kind of languages, like refinement types, or for example, union types, or even immutable types. You have a lot of types. You can just read the list, and there are mostly any type you want for your application properties. So, as we said, types are very important because first, they provide information about how to serialize and deserialize our mutable value to our snapshot value. So it's thanks to types that we can automatically generate an immutable snapshot. And as side effects, we can also have runtime, and if we use TypeScript, even build-time type checkings. Here starts a topic about reconciliation. I think that everyone here knows how React reconciliation works, but let's see what's the problem behind the scene. Let's say that we have our application store that contains to-dos, and we have created a work to-do and a sleep to-do. So we have created a new instance from a snapshot, and we push them into our application store. Suddenly, a new snapshot arrives from the server and says, okay, this is your new state. You need to drop off the old one and use the new one. Well, you may say, yeah, you can just apply snapshot and you get that back. But the real problem is that we need to ensure that work instance we created before, the reference, will be intact even after we apply the snapshot. We can't just delete everything we created before, delete every mutable instance we created before and create a new one, because reference need to be kept. And the first problem we see here is that we actually don't know if the work task has moved to the second position, or if the first one have changed. We don't know exactly how to do that. So, as we said, React already does that behind the scene. So, inspired by React, we implemented a reconciliation system that does mostly exactly the same thing. You start by defining an identifier property over your model, and that property will be used to identify the uniqueness of that model instance among the array. For example, we introduced the id property declaring, okay, it's an identifier, the identifier value will be a number. Then we need, obviously, to provide a correct snapshot that must now contain IDs. But thanks to IDs, now we know that work has moved to the second position, and it wasn't like we thought that the first position has changed its description. So what happens is that when we apply snapshot, now MobX-State-Tree is able to reconcile correctly and keep our reference integers. So they don't get broke when we apply a snapshot, because MobX-State-Tree will try to reuse any possible instance it can. And now that we have implemented reconciliation, there are some other patterns in React that are very nice. For example, lifecycle events. In React, when we define a component, we can have lifecycle for when we mount, unmount, etc. With MobX-State-Tree, we can define the action with special names that are called automatically whenever we create a new instance, attach those instances to another store, etc., etc. And to be honest, they kind of map between the React one and the MobX-State-Tree one, because what you may do in the constructor, you can do it in after create, component did mount is after attach, component will unmount is after detach, and when the component destroy, in React you didn't have an actual event handler. In MobX-State-Tree, we have before destroy. Up to now, we have spoken about our data representation and our data shape. But to be honest, we need to talk also about data transformation. As we have seen, Redux kind of sucks about how we define data transformation. Because one, data is collocated. And two, we have a lot of boilerplate to define a single change of a property, for example. So our to-do reducer will have a lot of code that may end up just toggling a property, for example, like we see here. But Redux has this really nice feature that you can have an action descriptor. Your actions are actually just action descriptor. So when you call your reducer, you pass the previous state, the action descriptor, and you get a new state. And that's because data is immutable. On the other hand, on MobX, this is impossible on the MobX world, because you are just calling a JavaScript function. So there isn't any descriptor at all. And also, we can, with MobX, we can change our application data whenever and whenever you want. So you are not constrained to do that in actions. For example, here I'm toggling the DOM property outside of any actions. So with MobX, unfortunately, we didn't get any action stream. And with Redux, we have a serializable, replayable action stream. That's really nice. So with MobX-State-Tree, we've decided that state can be only modified by default through actions. That's really nice. And action can only modify their subtrees, so their child properties. For example, if you try to change a property outside of any action, MobX-State-Tree will say, nope, you can't. That object is locked. You need to enter into an action to change that property. And the other fun part is that knowing the action attached to each model type, we can also wrap those actions behind the scene and provide automatically action descriptors. So that means that whenever you call an action on your object, for example, here I am calling the toggle method on the first to-do, you get automatically for free an immutable, serializable action descriptor. That's just the name of the function we are calling with their arguments and the path of where we are calling that action, referred to the root of our store. For example, here we say store.todos 0 toggle, so the path will be store.todos 0. And having them means that we can also apply them back, because given the representation, we can just recursively reach that object at that position, call the action with the given name we have in the immutable action descriptor, and call it with the provided arguments. So the apply action function in the MobX-State-Tree package helps a lot doing that. Let's speak a moment about observability. In MobX, we have fine-grained observability. And this what means? This means that in MobX, changing object properties is completely fine. It's encouraged to change object properties, because each properties is wrapped by MobX to have hooks to automatically dispatch updates of derived values. In Redux, instead, if even a property of our object state, so if our store changes somewhere, the reference of the object store needs to change. And that's how Redux signals that our store updated. With MobX-State-Tree, we opted out for having both. By default, we manage mutable data. So we create, as we said, MobX objects that are enhanced to work with MobX-State-Tree. So we have fine-grained observability. And if any value at any point of the tree changes, we just emit a new snapshot. Like we have just seen before in the demo, when I was changing our data in our input, we get a new snapshot on the logger. What this means is that when we define derived values that are also a part of our state, in Redux, you need to provide function to generate them and you need to manually memorize them. You need to manually memorize them because Redux doesn't know actually what this selector is doing. So it can't automatically optimize that. But that's very lightweight. On the other hand, in the MobX community, we settled down with using class getters enhanced with the computed decorator that automatically caches the value of the computed value, and whenever any of the property used by that computed value changes, the value cached will be drafted out and will be recalculated and then will be stored again and cached again. So we have performance optimized derived values basically for free without any memorizing at all. So with MobX, we get automatically memorized derived values, and with Redux, we need to manually memorize them. With MobX-State-Tree, we use MobX objects, so we can automatically memorize them. And to define them, we just define views over our models, and views aren't allowed to change state. They could only read state, and they will be automatically cached, as we said before. But there's more. Since we're dealing with mutable data, we have fine-grained observability. What this means is that whenever some property in our store change, we can get for free a serializable representation of that property changing. We are not speaking about action. We are going in a more fine-grained level that is patches. An action could change many properties. A patch is only a property changing. For example, here we see that we toggle the done property inside of some action, and automatically operation replace at the past to-dos done with the new value false. And of course, we can apply those patches back. You just need to import the apply patch function. What MobX-State-Tree will do behind the scene is just reaching that object at that level, and then, okay, you need to set the value in the provided snapshot, using it as snapshot. So we can even put complex values there onto the valuer property. It will be automatically serialized into a snapshot, and when applied, it will be automatically serialized back. So the awesome thing about snapshot is that we can also create a reverse snapshot. What it means that whenever we change something, we can also get the opposite operation. Is like, for example, we are adding a new to-do on our list. The opposite of adding a to-do would be removing that to-do. So with the onPatch function that you attach onto your store, you didn't get just the patch, but you also get the reverse patch. Unfortunately, the projector cut off, but you can see that here we are logging both the patch and the reverse patch. And here we see that we have the add operation that will add that value, but also the reverse operation that is removing that value. What really means, it means that we could implement something that basically we try to execute an action, listen for what that action is trying to change over our store. For example, here we are taking a list of our reverse patches, and whenever something will change in our store, we put the reverse patch in my list of patches. We will call our action the maybe possibly throw, and if that action throws, what we do is just taking the reverse patch list and apply back onto our store. So basically, we are just saying, okay, I did an action, that action throwed immediately, okay, just revert everything that action did. And it's really nice. That pattern is so nice that we provide by default, inside the MobX-State-Tree package, some function like record patches that allows to create a recorder over a store. Then you execute your function, and if something goes wrong, you can undo, and basically it does behind the scene what we've seen before. So it's like 10 lines of code behind the scene, and when we have when the execution of our function ended, we just stop the recorder and say, okay, you're fine, go up to the garbage collector. And what that really means, it means that we can take the advantage of that pattern for building forms or wizards, because you can just create a copy of an existing to-do into our application store, and you can let the user mess around with the to-do copy, and when you have performed your validation, you're sure that that to-do is fine, you can just say, okay, just take all the patches we have done before and let reply those patches over the real store. So first we create a fake one, we manage to let the user do whenever we want with the fake one, and then at the end reply the patches over the real one. Just because I missed the demo before. Here you can see that when I performed some action in our application, for example, I am toggling values here. In our patches section, they will be automatically generated. And also, we have, as we said, the stream of our action. Okay. So patches reminds a bit how Git works. Behind the scene, Git works with patches. It says what changed and provided that values to reconstruct your code. So patches provided a fine-grained seriality event for store changes. They are actually RFC, so they are spec compliant. And as we said, we get both apply and revert patches. We always speak about state tree, but is that correct, speaking about state trees? How many times you have seen a scenario where on your component you have to perform a lot of connects because when you select your state to display on your component, you need, along with the to-do, like we have seen today with the user and the repos example in the other talk, we need also to get the connected repositories, for example. Or here we have a to-do and we need to get the connected user. So it's kind of incorrect of speaking about state tree because our mind is more suitable to think about graphs rather than trees. But it's true that we can serialize cyclic structures. So what we usually do is just storing a user ID and you manually resolve its value. With MobX-State-Tree, we have a type that is a reference that automatically do that for you. Basically, it allows to serialize a value, but it's specified identifier attribute. And you can get and set the value on your store when using the Mutable API as it were the real instance, as you are dealing just with an object reference. For example, we say that the user has a model with a string identifier, and we have a to-do where the user is just a reference of the user model type. Whenever we are dealing with that, we can, as we said, just pass in the actual object reference, and behind the scene, MobX-State-Tree will provide that, will provide automatically that awesome serialized non-cyclic structure with identifiers. Let's talk a bit about MobX interoperability. As we said, MobX-State-Tree produces MobX objects that are a little enhanced. So that means that behind the scene, we can use MobX API, like reaction, that are functions that are automatically called every time this predicate returns a new value. So when the pending state changes, you get, okay, you have nothing to do, okay, let's log a message. And this means that you can use the regular observer from the MobX React package to render your MobX-State-Tree instance, because as we said, they are just enhanced MobX instances. And what about Redux? Let's think a bit on it. Redux snapshot could be considered our Redux state because it's serialized, it's non-cyclic, it's fine. So snapshots of MobX-State-Tree could be considered our Redux state. On snapshot could be considered our store subscription because, as we said, every time a new snapshot will get emitted, you will get a new snapshot. So like subscribe works for Redux stores. And apply action could be considered the Redux dispatch because we are given action descriptor produced by MobX-State-Tree and it will call the action connected on that model type. And our observer is for sure our connect. The fun thing is that we can actually convert a MobX-State-Tree instance into a Redux store for free. It's included in the package middleware extensions. And that basically used all the features we have seen up to now. So snapshot, on API snapshot, etc. to have a real Redux store. And the first thing you think about it when you speak about Redux store is obviously the Redux DevTools. This means that MobX-State-Tree instances can be connected to Redux DevTools. Here we can see that each time I called an action, I got here my MobX, my Redux DevTools with all my actions, and we can still use our features like, okay, I would like to watch this whenever we change, okay. So we get for free interoperability with Redux. Yeah, we just seen that. Okay, so I hope today to see here some from Jiki hands because I saw back in time this tweet from BuilderX, that's one of their latest products, and this tweet actually finds the problem with Redux. The problem with Redux is that we are developers, we are smart, we don't need to waste time writing match dispatch to props. And MobX-State-Tree can be used to achieve that without writing map dispatch procs. And another thing that I've seen about 1 hour before coming here to speak is that GKNs also provide a reactnativeseed.com website where you can have a starter package of a React Native project, choosing which technologies you want to include. So, for example, you can pick TypeScript. As you can see, it already provides MobX-State-Tree. So, if you want, go up there, pick your starter pack, and start coding. So, MobX-State-Tree, as we have seen, it's React, it's Git, but it's for data. Go out, install it, and thanks a lot for your time.
Questions?
One question. How does you integrate MobX with pure components?
View components?
Yes.
Okay. One awesome thing about MobX-State-Tree, as we've seen, is that we have an on-snapshot listener. So what you could do is just subscribe on snapshot and trigger any state synchronization with view you want. For example, I remember this repo of a guy that used some DOM in template literals library. I don't remember which, and he used on snapshot to automatically refresh the view and get the data updated. Or you can use, as we said, reaction from the MobX package, and it will be called whenever your data changes.
Okay. Thank you.
Hi, thanks for the presentation.
You're welcome.
I saw a similar presentation before in the Netherlands. I had an idea that MobX-State-Tree works instead of MobX, but seeing your presentation, it feels like it runs kind of on top of MobX. So how does it work?
I will be honest with you. MobX is always considered a state management library, but to be honest, MobX is just observable objects. You could compare MobX with Redux.js, for example, but comparing MobX and Redux is overkill because Redux is a state management architecture. MobX is just observable object that will be automatically updated and derivated and calculated. So, say that MobX-State-Tree is the real comparison between Redux. MobX-State-Tree is more a state architecture solution, while MobX just provides observable objects. For example, with MobX, you can use MVC, MVVM, whenever you want. You are not stick to an architecture. With Redux, you are sticking to an architecture. You need to flow flux. And the same thing with MobX-State-Tree. With MobX-State-Tree, you need to define models. So it's more a driven and opinionated solution. So it's good for people that starter because you give them exactly how to structure data in a way. They don't need to think how to put your data, where to put the action. The only place to do that is where the library allows it.
I will slightly rephrase my question. So can you run MobX-State-Tree without MobX?
No, behind the scene, it uses MobX. As I said, MobX-State-Tree creates enhanced MobX instances. So it uses MobX.
Okay, thanks.
You're welcome.
Someone else? Nope. Thank you, Mattia.
You're welcome.